right? So neutron. This is 1 plus 1. Yeah, just I think I made a mistake there. Right? 1. This is 0 and this is minus 1. This is called a negative meson. Negative meson. It's another particle. Right? Neutrons are heavier than protons. These are slightly heavier than the proton. This is a lighter particle. Slightly lighter. Slightly, yeah? Slightly. So this negative meson is the one that will hold the nucleus in place. This happens inside the nucleus. That is also another subatomic kind of particle. You don't need that. But like, if you forget about that reaction, will you? But then neutrons are really, really important. Really important to keep the nucleus stable. That is why if you have a one single proton, you don't need a nucleus. That's for hydrogen. You don't have one single proton. You don't need a neutron, right? You don't need a neutron. That is why hydrogen doesn't have any neutrons. But if you have two protons, right? Two protons, you have to have at least one neutron. You have to have at least one neutron should be there. Then only this neutron is the one that will stabilize. Now, for example, if you are a boy, right? Usually you are close to your mother, right? So if you can't approach your father, you approach through your mother. So your mother Amma is the one who will, make sure that both of you are kind of stabilized. Usually, I'm taking kind of older generation example. Nowadays, the families might be different. But then, so the neutron is also like that. When you have two protons, neutron is the one that will hold the two protons in place. And it's really, really important for the stability of the nucleus. So those things were kind of understood. But I'm like, we will not go into that kind of a detail. But these are fascinating material anyway, right? So they understood that, okay, so there should be neutrons. There should be neutrons. So you have to have protons and you have to have neutrons. So I will do this using a kind of triangle here. So these are the protons and this is a neutron. Right. So what are isotopes? Isotopes are elements that have the same number of protons but different number of neutrons. Different number of neutrons will give you different masses. So what is the mass of an atom? Mass of an atom is given by the number of protons plus the number of neutrons. Right? Number of protons is equal to the number of neutrons. Number of electrons. Then only the charges will be neutralized. Charges will be neutralized, right? So I will kind of paste a slide here for your information there. Yeah. So this is what you have. All these data is there, right? All the subatomic particles that are there. So the charges, protons and electrons, they have the same charge but different types of charges. The signs are different, right? The unit charges are the same. You can see here, unit charges are the same. This is -1 and this will be +1. Unit charges are the same magnitude wise. This is it. So these are the symbols that are used, +1 and this is the neutron. Now you can see neutron, the charge is 0. The unit charge is also 0. So you can see there are three main subatomic particles: electrons, protons, neutrons. But there are so many other subatomic particles also that people have understood later. But we don't want them. We will settle for these ones. They are the subatomic particles, right? So if you have an element, now there are 118 elements that we have discovered. People have discovered 118 elements. All of these elements, they have this atomic number and the mass number. Mass number is equal to the number of protons plus number of neutrons, right? Atomic number is equal to the number of protons. Number of protons in a neutral atom is equal to the number of electrons. So if I now give you a question, let us say you have some element X here, right? X element. Now here you write the atomic number. Let us say 80. Here you are. Let us say this is the mass number. This is the mass number. Let us say mass number is 80 and then atomic number is 42. This is the atomic number. Can you count and tell me what is the number of protons, what is the number of electrons, what is the number of neutrons, all these things, right? How do you calculate that? 80 and 42, number of protons plus number of neutrons is equal to 80. Number of protons is equal to the atomic number, therefore 42. So number of neutrons is equal to 80 minus 42, right? 80 minus 42 is equal to, what is that? 38. Number of electrons, how much? How many electrons are there? Can you tell me how many electrons? 42 electrons if it is a neutral atom. Is it clear? If you look at that atom, these are the like a combination that is there. So you, in the top left hand corner, you write the atomic mass number, and the bottom left hand corner you write the atomic number. Try this one. Let us say 75 Y 35. Can you tell me what is the number of protons, number of neutrons, and number of electrons? If it is a neutral atom, can you count and tell me? Can you all count and tell me? Protons, neutrons, and electrons. What are the numbers? Can you all work it out? What is the number of protons in it? What is the number of neutrons in it? What is the number of electrons? Number of protons, neutrons, electrons. Number of protons is equal to what? 35 is equal to 35. Number of neutrons is equal to 75 minus 35, right? 75 minus 35 is equal to 40. Number of electrons is equal to, what is that? 35. That's it. So kind of very simple ones. Now, if you take an element here, now let us say element, and then let us say you have simple A here, simple B here, and let us say there's a plus charge, plus N here. This tells you how many electrons that are removed. Plus means electrons removed. If it is minus means electrons gained. So how many electrons are removed, how many electrons are gained, so likewise. So based on that, I think you can do a calculation. Like for example, let us say calcium 40, let us say 20, and let us say 2 plus. Can you tell me the number of protons, number of electrons, number of neutrons, number of protons, number of electrons, and number of neutrons? Number of protons is how many? Right? Yes. So like you say, it is 20. Yes, 20. What is the number of neutrons? Number of neutrons, this entire thing, this box here, 40. Yes. 20 plus number of neutrons is equal to 40. So 40 minus 20 is equal to 20. Yes. Right. Very good. Number of electrons, how many? How many electrons? How many electrons? So this plus 2 means 2 electrons are removed. 2 electrons are removed. Total number of electrons you had was 20. So 20 minus 2 is equal to 18 electrons. So likewise, now I would expect you to kind of know like how many electrons, how many protons, how many neutrons are there. Like, that will help you to kind of work that out as well. Right. Okay. So moving on. Now the structure of the atom is not that simple. People understood that the electron doesn't have it behaves as a particle, but electron have a wave nature to it as well. Like not as just as a particle, but it has a wave nature as well. So electrons have wave nature. So not only particles, it has a wave nature as well. Now you remember when you look at the cathode discharge experiment, the other day, we understood that if you keep a Maltese cross, it will give you a kind of cast a sharp shadow on the other side. That means it looks like light. Light travels in the form of wave. So it has a wave nature. Electrons also have a wave nature. So somebody called de Broglie proposed this one. De Broglie proposed. So it's like a wave. So there's a whole new concept that began because of this. It's called quantum mechanics. So whole new thing began. And then people used quantum mechanics to explain the behavior, right? Behavior of electrons as well. Some of the very important new theories comes from this theory, which is called the quantum mechanics. Two things are there. You have the classical mechanics where you talk about the Newtonian laws, and the other part is the quantum mechanics, where you think electron to be not as a wave, not as a particle, but as a wave, right? And then people did so many experiments and they realized that the atom is not that simple. You have the nucleus, right? And then around that you have different energy levels, right? Inside these energy levels, you have these sub-energy levels as well, right? Inside this, you have sub-energy levels as well, like that, right? Inside the principal energy level, you have sub-energy levels. It is just like you go to a hotel, or maybe your impressive campus, right? Like let us say there's a like kind of a tall building, and you have different levels in them, right? First floor, second floor, mezzanine floor. Likewise, you have these different floors, right? Now, if you go to a kind of a big hotel, a skyscraper like that, you have several layers, floors. And inside each floor, you have different rooms also, right? So likewise, inside these important energy levels, there are sub-energy levels where the energies are slightly different, right? Energies are slightly different, and people have identified 4 different sub-energy levels. 4 sub-energy levels. right? One is called the S sub-energy level. Second one is called the P sub-energy level. Third one is called the D sub-energy level. Last one is called the F sub-energy level, S, P, D, F. They are letters for certain things. S is for sharp. Sharp. So when you draw it, like, you guys are computer experts. Like, if you take this wave function and plug into the computer and then draw a three-dimensional picture, their boundaries are really sharp. The boundary is very sharp. So that's why it's called sharp. P is for principal. D is for diffused. And F is for fundamental. So there are 4 different types of sub-energy levels, S, P, D, F. A sharp sub-energy level 1 was called principal sub-energy level. The second one was called diffuse sub-energy levels and fundamental sub-energy levels. Right? Now, in any level, S sub-energy levels, you have only one. One S sub-energy level. There's only one room S sub-energy level. Now, think it like this, SPDF is like you go to a hotel room where you have different facilities. S is just like the bed. That's it. This room, it provides just a bed. That's all. It might be cheaper, right? The cost is less, but then you get a kind of limited facility. P is little better maybe, the bed and the attached bathroom. D is little better, bed, attached bathroom, and I don't know, something else. Good satellite connection, right? Satellite, TV connection, right? So these 3 things are there. 4. F is like, you have the bed and the bathroom, attached bathroom, satellite TV connection, and a plunge pool, right? So it's something like that. It's exactly like that. So depending on their, the type, you see their different. So S, you have only one sub-energy level. S, one sub-energy level. Right. P, you have 3 sub-energy levels. Right. So, in one single flow, there are 3 equal type rooms. That's it. That's like that. We'll think it like that. Right. D, you have 5 such sub-energy levels. 5 of them. Right. And then F, you have 7 sub-energy levels. So I'll try to give you the shapes. Just get a kind of a quick glance at it and just leave it there. So this is your S sub-energy level. So S sub-energy level is like a super sharp boundary, and it's a spherical type, 3-dimensional spherical. It's like that. So it's a sub-energy level. It's like that. So if it is 1s, it is a smaller orbital, and the 2s is like kind of little bit bigger orbital. It's a bigger orbital. This is smaller. This is bigger. So you go away from the nucleus more and more, it becomes bigger and bigger and bigger. So that's the first one. So sub-energy levels are like that. Then you have the P sub-energy levels. P sub-energy levels are like this. There are 3 P sub-energy levels. I told you there are 3 of them. So these 3 P are, these are like dumbbells. I'm sure some of you are doing weights and all. You might have used dumbbells. It's like this side and this side. Like, there's that. And they are oriented in one direction. This is one of these will be oriented to your side, and the other one is oriented to this left-hand side, and the other one is oriented in the perpendicular direction. So there are 3 p sub-energy levels. 3 of them, right? Very, very simple sub-energy levels. They are like dumbbell shape, like this, right? Something like that. So this tells you the shape of that container holding the electron. It's like that, much more complicated than that. But let us think it in that. So 3 of them. And then you have D sub-energy levels also. D sub-energy levels are like, much more complex than that. Like you can see that here. The D sub-energy levels are even more complex. D sub-energy levels. There are 5 of them. So you have 5 D sub-energy levels. 5 D sub-energy levels. These are the ones that will hold the electrons. They are like the containers. They hold the electron in place inside this. And the last one is, it's like, there's a complete different part of chemistry, which is called computational chemistry, which I don't know anything about that. But your doctor, whoever, Amali is an expert in computational chemistry, as I understand. So maybe, if you are interested, you talk to her. She will guide you. Like now, like you can draw these things. You can put an equation, draw them. Like, you can write programs, and then there are a lot of things that you can do. Right? It's a complete different branch of chemistry. Right? So there you have this one. This is like, you can't draw it on a piece of paper. You can see that. You have to have a computational power in order to get these equations done and get those diagrams in the right order, like, how they are oriented. All these you can do, like, maybe using software. These are like, 7 of them, 7 very complex F blocks, F sub-energy levels. 7 F sub-energy levels. So what is the summary there? Summary is like, you see, like, you're seeing a kind of complete new world, right? So you see the atom, the nucleus is there. Nucleus is composed with protons. You have to have neutrons to balance them, like, keep the nucleus under stable conditions. You have to have that. And then, like, electrons are in different energy levels. When you have them in different energy levels, in each energy level, there are sub-energy levels also. You have the S sub-energy levels, there's P sub-energy levels, there's D sub-energy levels, there's F sub-energy levels. Things are becoming more and more complex. Think about a complex hotel room. Not a hotel room, okay. Think about a very, very, like, skyscraping, complex hotel, right? You have like rooms with different facilities, and they become more expensive. Expensive means you need more energy. It's like that. So it becomes more complex. So in your first energy level, right? Let me draw that again, right? So this is your nucleus. This is your nucleus. Now you have the first energy level, then you have the second energy, and all the fifth energy level and sixth energy level. So likewise, you have these different energy levels. In your first energy level, you only have the S orbitals. There is only one S. That's it. Only S. When you go to the second energy level, this is the first energy level, right? When you go to the second energy level, there are 2 of them, S and P, right? There are 3 of them, right? You go to the third energy level, you have S and then P, the next one is D. S is 1, P is 3, D is 5. Look at the first odd numbers, 1, 3, 5. And the fourth one fourth energy level, and beyond that, for all other energy levels, you have four of them, which we were talking about. S, P, D, and F. One S orbital, P, 3p orbitals, D, 5d orbitals, and 7f orbitals. From all of that, beyond that, you have SPDF 1357. Okay. So you can see that it becomes more and more complex. But we will not go beyond that. You know, that is enough. That complexity is enough, I think. Right? So this is what you have. Right? And then how, all these energy levels, they contain electrons. And we are going to see how electrons will fill into them. Right? So now we look at filling electrons into them. Electrons goes according to a German, German, like in German, this is called Aufbau. Aufbau, I think, or the Aufbau. There's a certain rule that you can work on. So how do you look at the rule? Let me put a picture on this according to this rule. Right? This is how electrons are filled. Right? First, it goes on to the first S orbital. Right? It goes on to the first 1s, and then from here you get 2s, from here you get 2p, 3s, 3p, 4s. So likewise it keeps on going, right? But at your level, we wouldn't expect much, at least you can come to 4s, that will be great. So if you have one electron, first one is hydrogen. Hydrogen contains one electron. One electron means you can have only one S. Only one S. Right? There is first, one means first energy level. S sub energy level, you can have one. That's it. Every sub energy level, you can hold two electrons. Two electrons. Now, for example, now if you think about this hotel, each and every hotel room can accommodate two people. Every room can accommodate only two people. It's like that. Hydrogen. Next one is 2, helium. There's 2 electrons. U1s, we say 2. Right? I hope you got it. 1s, 2. Right? So start from that arrow, red arrow. 1s. There's only one electron, so 1 electron. Helium is 1s, 2. Because you can accommodate 2 electrons. Now it is full, you can't accommodate anymore. Right? Helium. So the next one is lithium. Lithium contains 3 electrons. So 3 electrons, how do you put? 1s, 2. Now you have 2 electrons. After 1s, where does it go? It goes to 2s, isn't it? It goes to 2s. So we say 1s, 2, 2s, 1. Do you understand what I say here? Do you understand that 1s, 2, 2s, 1? There's only one, there's another one electron that goes into this. S orbitals can accommodate a maximum of 2 electrons. Now the next one is beryllium. Beryllium contains 4 electrons. It is called 1s2, another 2 electrons. Now those 2 electrons you can accommodate into 2s2. Beryllium. Then comes boron. Boron, you have 5 electrons. So we say 1s2, now 2s2, that's it. That's the maximum electrons. So we are here. At the moment we are here. After 2s2, you have to go to 2p2. Right? 2p2, but then you have only 1 electron. So you say 2p1. 1s2, 2s2, 2p1. If you add all these things, you should get 5 electrons at the end. So this is 2, this is 2, 1. 2, 2, 4 plus 1 is 5. Right? Now the next one is carbon. Carbon, it has 6 electrons. 1 is 2. Yeah. I hope you can see the screen. Nah? 1 is 2, 2 is 2, this is 2p2. 2p2. P orbitals can, like there are 3p orbitals. 3p orbitals means you have the first p orbital, second p orbital, and the third p orbital. You can have a maximum of 6 electrons. 1, 2, 3, 4, 5, 6. Altogether 6 electrons you can accommodate. So 2p2, right? 2, 4, 6. Now the next one is nitrogen. Nitrogen means 7 electrons. 7 electrons gives you 1s2, 2s2, 2p3. Oxygen, 8 electrons. 1s2, 2s2, 2p4. Chlorine, 9 electrons. 1s2, 2s2, 2p5. Neon, 10 electrons. You say 1s2, 2s2, 2p6. So likewise, it keeps on adding, right? So p orbitals, you can have a maximum of 6 electrons. P orbitals maximum 6 electrons, right? S orbitals, you can have a maximum of 2 electrons. Maximum 2 electrons. The maximum 6 electrons, right? Let's look at the next set of elements. I will keep on writing the elements. Sodium, silicon, phosphorus, sulfur, calcium, and calcium. I would like you to at least want to be able to work up to that point. 20, at least up to that point. So here 11 electrons, here 12 electrons, here 13 electrons, this one is 14, this is 15, sulfur is 16, chlorine gives you 17, argon gives you 18, potassium gives you 19, calcium gives you 20, right? Would you be able to work on that? Work on the electronic configurations here, right? 11 is 1s2, 2s2, 2p, 2s2, 2p6, 3s1. Because you go for after 2s, after 2p here, yeah, get 2p. From 2p you go to 3s, right? So that's why we are going for that. So you get 1s2, 2s2, 2p6, 2s2, 2p6, 3s2. This one is 1s2, 2s2, 2p6. This gives you the energy level. Second energy level, second energy level, the third energy level, third energy level, likewise. 3p1. And this one is 3p2. This one is 3p3. This one is 3p4. This one is 3p5. This one is 3p6. Right? Now, after 3p6, you have to have 4s1. This one is 3p6, 4s2. So likewise, you can write the electronic configuration. Based on this electronic configuration, they have made this thing called the periodic table. That's the periodic table, right? So you see the hydrogen here, hydrogen, and then comes the helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. And then you have these all the other elements. But then don't worry about those elements. At least look at the 20 elements in the first periodic table. And then maybe look at the 3D. We will look at that. We'll try to understand, right? So there, maybe I will like kind of stop today, and then we will look at a little bit more on the periodic table next time, right? I want you to maybe work on a tutorial, looking at these SPDF things and atomic structure. I want you to kind of look at that, right? Okay. Okay, then. Thank you very much. Thank you. Thank you very much. Good night.